Hi everybody, Chris Bryant here, and welcome to your free CCNP Switch Video Bootcamp, brought to you by the Bryant Advantage and our friends at Udemy. Online courses anytime, anywhere. First off, thanks for watching the introductory video, because no one ever wants to watch the introduction. They want to go straight into the course and get started. I understand that. I'm with you. We're just going to take a minute or two here to take a look at what you're going to get in this course, and we're going to start though with what you don't get. Don't worry, you're going to like this. First off, you don't get a bill. We all like that. It's a free course. You're not going to get a bill. Secondly, you're not going to get continual sales pitches, because the reason I mention this is that with any free course sign up or free email sign up, free sign up for anything, you can't help but to think, okay, what's the catch here? There is no catch here. I'm not going to insult your intelligence, though. I hope you'll check out my page, CCNP Switch and CCNP All-in-One courses here on Udemy after you watch this one. If you like it and you keep the videos, you don't sign up, no hard feelings. Maybe a few hard feelings. But, in all seriousness, I am not going to continually bug you about signing up for something throughout this course. What you are going to get throughout this course, though, is an hour and a half, actually a little over that, of lab-packed, world-class CCNP Switch Video Bootcamp instruction. And every demo I do here for you is going to be on a live Cisco switch, and there are plenty of them. Because especially when it comes to the hot standby routing protocol, HSRP, the topics, it's one of these things that when you read about it, it takes a while to sink in, if it ever does, just by reading it. But once you see it in action, it's like, oh, okay, it's not really complicated. HSRP isn't complicated, but you need the right demos to learn it, and you're going to find those right here. We're going to have demos of the fundamentals. We're going to take a look at the default. We're going to run a live lab on the active router election, and if you don't know what that is, you will about 90 minutes from now. And load balancing, kind of. You'll see what I'm talking about. HSRP load balancing isn't quite pure load balancing. You need to know why for your exam and for the real world, and you will see why in this free course. Also, the one HSRP topic that really trips people up, especially if you've just read about it, it's called interface tracking. And once you see it in action again, not only will you see that it's pretty straightforward stuff, you're also going to see how handy it can be in real-world networking. Because my courses aren't just for the exams. There are things you can apply in the real world as well. That's just HSRP. Then from there, it's on to Cisco switch security. We're going to review some port security fundamentals, because that's important stuff. You learn it in your CCNA, but I don't know if you got your CCNA 3 days ago or 3 years ago, so we want to make sure that these fundamentals are in your mind. We're also going to set some max address limits, do some sticky addressing, and go over a mode that's really misunderstood, but you will not misunderstand it once you're done with this course, and that is the error disabled recovery mode. That wraps up the introduction. I appreciate you taking a couple of minutes to watch it. I'm Chris Bryant, and on behalf of the Bryant Advantage and Udemy, welcome to this course. Let's get started. As we talk about hot standby routing protocol and see it in action, which is going to be very shortly, we've got several great HSRP labs for you in this section. I'm going to be referring to routers rather than saying switches or L3 switches or multi-layer switches, because the HSRP terminology itself does refer to active routers and standby routers. The theory and commands of HSRP, they run the same on a multi-layer switch as they do on a router, and in the lab we actually will be using multi-layer switches. Also, the icon that I'm using for multi-layer switches from here on out is slightly different. There's no SI in the middle. I just wanted to make sure that you saw both versions of that. Now, HSRP is defined in RFC 2281, and it's a Cisco proprietary router redundancy protocol. What we're doing is we're putting physical routers into an HSRP router group. One of the routers in the group is going to be selected as the active router. The others are going to be the standby routers. And it will not surprise you to learn at this point that the active router is going to handle the actual workload, and the standby routers, frankly, are going to sit there and they're going to stand by and watch the active router do all the work. Now, HSRP does ensure a high network time because we are routing IP traffic without reliance on a single router. Also, just a quick note here, the terms active and standby, they don't refer to the actual operational status of the routers. The backup router or the standby router, it doesn't go into some kind of suspended state. It's ready to go. It's just referring to its status in the HSRP group. Here's actually what we're doing with HSRP. Now, the actual IP and MAC addresses of the physical routers in the group, They're totally unknown to downstream devices. And in this case, that being our switch and a bunch of hosts connected to that switch, these devices are actually communicating with a router that does not exist. A pseudo router, a more popular term, a virtual router, and that's going to be created by the HSRP configuration. Now this virtual router is going to have its own MAC address, it's going to have an IP address that we assign it, and the downstream devices send data using those as the destination addresses. It's pretty cool stuff. So we're going to jump right in here with a lab. And in our first lab, we're going to have multi-layer switch 1, which has an interface VLAN 100 with an IP address of 172.16.23.1, and multi-layer switch 2, which also has an interface VLAN 100, address 172.16.23.2. Those are the two routers we're putting in the HSRP group. We're going to create a virtual router with this configuration with the IP address 172.16.23.12/24, and it's that address that will be used by all the hosts in VLAN 100 as the default gateway. So here's a diagram for you as well showing you those addresses, and let's go ahead and get started. Let's bring the live equipment up. Now I have pre-created, if you will, I've already created the interface VLAN 100 on both devices. And we'll just do a quick verification here. Here's show VLAN 100. It's up and up. There's the IP address 172.16.23.2. Now let's go over to multi-layer switch 1, MLS1. You can see, whoops, that should be 100. There we go. And interface VLAN 100 is up. Everything looks good there. 172.16.23.1/24 is the IP address. Just wanted to make sure I did show you VLAN 100 for number 2. Okay, so those again are the IP addresses that we're working with, the two devices, and we're going to create this virtual router at 172.16.23.12/24. We're going to start over on router 2. And these are interface level commands. Standby is the word we just keep coming back to. You are rarely, if ever, even going to type HSRP. But standby, I've got quite a few options here. Some we're going to look at in the next couple of labs. And the one we're going to look at right now is your only required one, IP. And that's enabling HSRP for IP version 4 and setting the virtual IP address, which is a good idea. So without that, we're kind of stuck. So let's see what we need before that, though. We actually need a group number, and I'm going to put 5 for ours. And I'm going to then enable HSRP for IP version 4 with IP. Then I'm putting my virtual address, 172.16.23.12. You could make it a secondary virtual IP address. I'm not that much on secondary addresses, and that's not something we're going to cover in the labs anyway. It's beyond the scope of the exam. And we're just going to stop right there and see if anything happens. We'll get a little console message, and let's run show standby. We're going to be running this one a lot. And state is listen at the very top, and I'm going to show you all the states. We'll discuss those and look at the order of them. But right now it's just listening for something. And let's go ahead and finish the config over on MLS1. Standby 5, IP 172.16.23.12. And that's it. Now let's go back over to switch 2. This may take a minute or two to finish cooking, so to speak. As you can see, state is active. It's showing a couple of state changes. We see the virtual IP address. There's an active virtual MAC address as well. We didn't enter that, but there is one. And let's see. Standby router still unknown. So let's give that a moment to cook, so to speak, and let them talk to each other. And now you can see it's changed from standby router is unknown to a few seconds later, standby router is 172.16.23.1, priority 100. And it looks like things might have settled right there. So you can see we had another state change. That's been about 53 seconds. This is the active router. Active router is local. Standby router is 172.16.23.1, which is router 1. So let's just go ahead and verify that. Trust but verify. Show standby. Group 5, you can see that one state change was about 44 seconds ago. The state is standby. There's the same virtual IP MAC address. We expect that. There's the same virtual MAC address. Something called preemption is disabled. You see the active router 172.16.23.2. We see its priority, and there's the standby router is local and the priority of the local router. So far so good. That's exactly what we expected to see. What we saw on switch 1 verified what we saw on switch 2. And let's go down. We've seen all this on the board. One thing I did want to show you here, you cannot assign an IP address from the multi-layer switch as the IP address for the virtual router. And here on this line I tried that. Standby 5 IP 172.16.23.1. The router told me address cannot equal interface IP address. I'm the one who added, so don't try it. Cisco doesn't have that much of a sense of humor, but I do. So let's go down the roll here, down the line. We'll start with MLS 2. And let's go down this information one more time, because you're going to go to show standby. This is your #1 verification command. It's your #1 troubleshooting command. You're going to keep coming back to this, so we really need to know the information we can expect to find. First off, here's your VLAN number, and it's in group 5. State is active, and again, we'll come back to those states here shortly. We've had 2 state changes, and the last state change was 2.5 minutes ago. If you see these continually changing in what you think should be a stable configuration, then that's a tip-off that it's not a stable configuration. You've got something wrong. There's no reason for HSRP state changes to be a regular thing, like every couple of minutes. Definitely shouldn't happen. There's our virtual IP address for the router itself, the virtual router. Again, there's that MAC address. And you notice V1 default here. Version 2, I believe, is for IP version 6, and that is way beyond the scope of the NP switch exam as far as HSRP goes. So we've got our hello time here of 3 seconds and a hold time of 10 seconds. Those must be the defaults because we didn't send them. It even tells you when the next hello will be sent, down to the thousandth of a second. That's pretty exact. Preemption, again, is disabled. We'll talk about that shortly, I have a feeling. Active router is local. There's our standby router 23.1. Even tells you what the priority is. Tells you the priority of the local device. And then finally the group name, not something we get into a lot, but that is the default name, and you'll notice the group number is at the end of the default name. So a treasure trove of HSRP information in there. Tells you the states, the IP addresses of the standby, tells you whether you're the active or not. A lot of great stuff. If we go back over to switch 1, and let's get a fresh show standby there. We have the same fields, just of course the information is a little bit different. You can see the last state change was almost 4 minutes ago. State is standby. There's that virtual IP. Let's talk about that virtual MAC address, though. We know where the IP address came from. We're the ones that entered it. That's the one required command you have. Well, where did that MAC address come from? This is derived from the well-known MAC address that's reserved for HSRP. So most of that address was predetermined. Almost all of it, actually, 0000C 07 AC, all of that is predetermined. The 05 here, that's the only part that isn't predetermined. Now that is the group number, and I know you're saying, hey, no kidding, but it's the group number in hex. So you need to brush up on your hexadecimal before you take the switch exam, because that could creep in. And of course, if you saw AC0A here, the group number would actually be 10. If you didn't know that, you do need to brush up on your hex. Nothing wrong with that. Just a quick story here. It was a long time before I even started running courses like this. And it had been a very, very, very long time since I saw hex on any certification exam, anything. And the day I took the CCIE lab, there was some hex at the very beginning of it. And if you couldn't solve this, then you couldn't do the rest of the lab. so I had to wait until some brain cells came back there after a few minutes. There was a moment of panic, but you don't want that panic on your exam. So just take a few minutes to brush up on your hacks before you take the switch exam, and you will be fine. But that is exactly where the MAC address comes from. And here's our current network. MLS2 is the active switch, MLS1 is the standby switch, our virtual router 172.16.23.12. That also concludes our first lab. What we're going to do next is talk about that election process and how to change the results if we're not real crazy about it. We'll do that in a lab at the beginning of the very next video. See you there. One quick addition to that last lab before we move on to the router election. One thing you should do after you've got your virtual router up and running and everything looks good on your multi-layer switches is to go to one of your hosts and make sure they can ping that new virtual router. So I just went out to host 3, which was already in VLAN 100, and pinged 172.16.23.12 from there. No problem at all, and the pings came right back. So let's talk about this election for a few minutes, and then we're going to jump in the lab really quick and look at changing the results of this election. The priority, that HSRP priority, it's the first value considered in the election. Now the priority is 100 by default. We saw that on both routers. And just a quick reminder of where to find that. Of course, you know it's in show standby. Everything's in show standby. But your local router is going to be right down here, your priority. Priority 100. Notice it says default 100. I think that word in front of the number there in the paren is going to change, so we want to watch that. But there's the priority. So everything looks fine there, except should there be a tie? Well, there always will be a tie if we leave the routers at their defaults. Theory holds that the router with the highest IP address wins the election. Now, multi-layer switch 2 won the election in our first lab and had the highest IP address on the SVI. So the theory holds true, and that could be any interface. But the problem there is that doesn't always work, and I'm speaking real world here. Always, always, always verify your active router. I know I say to verify everything, but you really want to verify this because I've seen routers with lower IP addresses win that election, and the priorities are the same and everything else is the same, so you just want to verify that. For your exam, we're going to hold to the theory that the highest IP address wins the election. So let's go ahead and make multi-layer switch 1 the active router, because we know in the real world, it's just like our root switch elections. We don't always want to leave that up to the MAC address. So maybe I've got one particular workhorse switch here and another one that's not so much. So I want to make the first switch the multi-layer switch. So let's just go into inner VLAN 100, interface VLAN 100, standby 5, and we just use the priority option. And your priority is 0 through 255. So I'm going to go double or nothing here and double the default priority. And to get a console message, but it's just the old configured from console by console message. We're pretty used to seeing that one. We don't see anything about a state change though. And this is good and bad on MLS1. The good part of it is that the priority change did take effect. There it is. Priority 200, configure 200. Whenever we see configured, we know that somebody hard-coded that particular priority. The bad news is that there wasn't a state change. We could see here first off state is standby. So router 1, multi-layer switch 1 didn't take over as the active. And the last state change was 9.5 minutes ago. So, not so much here. What happened? Well, the deal is with HSRP that either, in this case, multi-layer switch 2 has to disappear for 1 to take over in its absence. We don't really want to do that. We don't want to reload the switch. What we'll do much more commonly is use the preemption option. Okay, preemption is disabled by default in HSRP. And here's the preempt option. Overthrow lower priority active router. Sounds kind of violent. I don't overthrow. That's pretty violent. But that's the only option. That's the one we're going to use. When you enable preemption, then a router can take over as the active if it has a higher priority than the current active. Because right now, switch 1 has a priority of 200. Switch 2's got a priority of 100, but it's keeping its role as the active. Let's see what happens when we enable preemption. And you just put preempt, and that's it. And in a very short period of time, and I'll move this over so you can see it, I know that timestamp is long, the state change, HSRP 5 state change, VLAN 100 group 5 state standby to active. So it sounds like it did exactly what we wanted it to do, and it did, because now this is the active router. This is the active router, 2 state changes. It just changed 17 seconds ago. All the IP address and hello time and all that stuff stays the same, but preemption is enabled. Active router is local, and here's the standby router 23.2 with a priority of 100. Remember, the priority it mentions here is the priority of the local router. So it did exactly what we wanted it to do, but that's the key. It's not enough just to go in there after the election and raise the priority of the switch you want to be the active router. That's not enough. You've either got to reload the active router, which we generally don't want to do, or just enable preemption. There is one option here too. I'm going to show you this. There are some options there for preempt. Because those of you who've seen, and you might still see an iOS version where this happens, you used to be able to set preempt at the end of the priority command. And I don't think you can do that anymore, period, but you might bump into an older iOS that does let you do that. I do want to show you these options, though. You can delay the preemption. So if you want to say, okay, I want to wait 10 seconds before preempting, or I want to delay it until after a reload, then you can do that. You might run into specialized situations where you want to do that. The sync option, do not concern yourself with that right now. But let's look at minimum. And it's just the number of seconds for minimum delay. So, again, you might run into some specialized situations out there in real world networking, but generally for lab work, it's good. They're good options to know, please don't get me wrong. But generally, when I preempt, I want to go ahead and just do it right then and there. That's really it. So that is it for this particular lab. We are going to head to the next video now. We're going to talk about those state changes. We've seen a couple of those in action. We've seen active, standby, certainly. We've seen active and standby in all of our labs. But I want you to know about the stages that lead up to those, and we'll talk about that on the very next video. Before we start on our next lab, let's go over these HSRP states. We've seen a couple of them, especially standby and active, but let's go through them in order. Disabled is officially the first HSRP port state. It's very similar to STP in that you won't actually see it mentioned. You won't see HSRP disabled in a console message, but it is the first official port state. Now, initial or init, the interface enters this state when you first enable HSRP on it. HSRP isn't actually running at this point. The only other time I've ever seen that, it's in a lab environment, thankfully. If you went in, let's say right now on one of the routers and deleted interface VLAN 100, you would see the HSRP state go from active or standby, depending on which one you're on. If you're on the active, it would go from active to init, and then it would just sit there, which is not what we want. Now listen, that's the next state, and that's when the router knows the virtual router's IP address, but it is not yet the primary or a standby, and it's listening for hello packets from those routers. In speak state, the router is now speaking, it is sending hello messages, and it's participating in the election of the primary and standby. Standby, we've seen that a couple of times. The router is a candidate to become the active. It continues to send hello packets, and then finally active, the router is now forwarding packets sent to that group's virtual IP address. Speaking of forwarding packets sent to the group's virtual IP address, let's talk about load balancing here for a bit and see it in action as well. Now, I have reset things from the previous lab as far as the priorities go, so right now everything is back at the default, and switch 2 is the active router for our group. Switch 1, of course, is just standing there, standing by, and watching MLS2 do all the work. Now, assuming that we had 60 hosts in VLAN 100, that means that right now, switch 2 is handling the traffic for 60 hosts, and our other multi-layer switch 1 is just standing by, watching. We would like to do a little bit of balancing here. Now, this balancing is going to be a little bit different because it does require a little bit of cooperation from the hosts. And we'll talk about that after we get the switches up and running, because I guess tricking may be a harsh way to put it, but we're kind of tricking HSRP a little bit here as far as I'm concerned, because what we're going to do is create another group. Right now, HSRP Group 5, it has Switch 2 as the active router, and that group is using 172.16.23.12 to represent its virtual router. What we're going to do now is create Group 10 with the same two routers. There's nothing illegal about that yet. We'll find out in a minute, I guess. Making sure that one is the active, Switch 1 is the active, and that group will use another address, 172.16.23.21, for its virtual router. So this is what we want to end up with, in essence. We want to split this load. It's not pure load balancing, of course, because we could have some hosts sending a lot more traffic. But the thing is, it's better than what we had. So in the end, we want Switch 2 to remain the active for Group 5, but be the standby for Group 10. We want the inverse, really, for Switch 1. We want Switch 1 to be the active for Group 10, but the standby for Group 5. Okay, so we're already halfway there because we know that Switch 2 is the active for Group 5. And let me move that up. And we can just verify right here, of course, before we start a lab. Show standby, VLAN 100, Group 5. State is active. So let's go ahead and create another group. And we're going to start that over on Switch 1. And we just go right back under VLAN 100. But this time, of course, we're using standby 10. That's our new group. 172.16.23.21. That's going to be the IP of the virtual. Standby 10. We're going to go ahead and double the priority again. And we're going to let this one preempt. And that's all we need there. We need even less over on MLS2. Move that. And let's try that again. VLAN 100. Just came right back. Standby 10. IP 172.16.23.21. And that's it. So we're going to let that cook for a minute here and see how it goes. Actually, let's go over to 1 and see what it's saying already with show standby. And when you run show standby there by itself, it's going to give you the info on all the groups. And you can see that it's still the standby for Group 5. But Switch 1 is now the active for Group 10. Now it says standby router is unknown, so it's not done yet. But let's go ahead and run it again now. And you can see that we get exactly what we wanted. Group 10, Switch 1 is active. There's the IP address. There's the MAC address. Notice the 0A at the end of it. Remember I told you a Group 10 would be 0A there because it's hex. There you go. Preemption's enabled. Active router is local. Standby router is 172.16.23.2. So that's exactly what we wanted. Let's go over to Switch 2 just for fun. And we can see that in Group 5, this switch is the active router. Active router is local. Standby is 23.1. And for Group 10, the story is a little bit different. Group 10. Let's try that again. Group 10. And we've got active router is switch 1, 23.1. And the standby router is local. So that's all there is to load balancing. Again, it's not absolutely perfect, but it's really, really good. And here is essentially what we have now. We're going to test this in a moment. Because remember I said something about the hosts? We're not quite done with our load balancing until we give about half of our hosts one of the virtual router IP addresses for a default gateway. Then we give the other half of the hosts the other virtual router's IP address as a default gateway. That's the way you got to split it up. So you can see here, just using two hosts, we've got host 2 with its default gateway pointing to 172.16.23.21, and that's the path it's going to take. And then host 3 has a different default gateway. It has the other virtual router's IP address 23.12 set as the default. So let's go ahead and send some pings there and just make absolutely sure. Let's see if we can get that up there to stay this time. And we've got 2. We're going to head out to router 2. and do a 172.16.23.21. No problem there with it pinging its virtual, its default gateway, which is a virtual router IP address. Now host 3, we're going to ping the other one. And all is well. So that's really the key, is that you just have to remember that you're not quite done with your load balancing when you get that second virtual router up and running. You are done with it when you go to your hosts and you change some of their default gateways, half of them pointing to one, half of them pointing to another, and you're all set. That is it for load balancing. Now next up, we've got something called interface tracking. It is an absolutely fantastic feature you're very liable to run into in the real world, and you're definitely going to see it on your exam. So let's head to the next video and we'll run that lab. HSRP interface tracking. This is a great little feature, and what it does, it enables HSRP to monitor an interface that you and I as the network admins specify, and the status of that interface will dynamically change the HSRP priority for a specified router for better or for worse, and let's find out which one that's going to be. When that tracked interface's line protocol goes down, the HSRP priority of the router is decremented. Of course, a fancy way of saying it goes down. Now, this can lead to another HSRP router in the group becoming the active, but that other router must have preemption enabled. Now, in this diagram, I have not indicated or not put the virtual router in there. We know it's in there, and we're actually going to configure that, because I've got these IP addresses, the interface VLAN 100, but that's it. So we're doing everything else from scratch in this lab. And what we're going to do is set MLS 2 up with a priority of 105. It should, of course, become the active because it's going to have a higher priority than 1, which we're going to leave at the default priority of 100. Well, as a result, then 2 will handle all the traffic sent to the server behind MLS 1 and 2 here. You can tell it's a very important server because I put a giant bag of money next to it. Well, there's nothing really wrong with that, but there is a single point of failure, and it might not be the one you're thinking about that could cause some trouble. And again, the IP addresses shown for the multi-layer switches in this lab are for their SVI for interface VLAN 100. The problem here is that if Fast Ethernet 3 on switch 2 fails, the hosts in VLAN 100 can't get to the money bag server or whatever server we've got back there. But by default, that Fast Ethernet port going down is not going to affect HSRP in any way. It's not going to bother it at all. So what we're going to do is change that default a little bit and put some tracking on there. First, we're going to go ahead with a configuration, but first, I've got something here to show you. On switch 2, I've got show interface Fast Ethernet 3. Save yourself a lot of time and agony when you're configuring HSRP interface tracking. Always check the status of the interface before you even start. Because if there's something wrong with this interface and you don't realize it, then you're going to get some comeback or some feedback from your show commands in HSRP that you're not expecting. And you end up troubleshooting your HSRP config because that's the last thing you did when the actual problem was the interface you were tracking was down already. Not that that ever happened to me. I just heard it, from a guy, so I'm sharing it with you. Okay, I'm lying. It did happen to me. Not here, but I did learn that lesson the hard way. Let's go ahead and get started with our basic config. We'll go with standby group 1 this time. 12. I try to put 12 in there. 16.23.12. And we're going to set the priority to 105 there, and that's going to be it. And that's it. So right now on switch 2, use the standby IP command to enable HSRP, create our virtual router. Then I set it with a priority of 105, interface VLAN 100. I enabled HSRP, same address, of course, same virtual router, and enabled preemption. So let's go forward. Let's take a look at 6s here and just make sure. At switch 2, and you can see you've got a couple things, all of which we really expect to see. There's VLAN 100 group 1 state is active, preemption disabled by default, active router is the local, standby router is 23.1, and there's priority 105, and of course it says configured 105 because we put that in there. Let's go back to switch 1 for a moment. Run the exact same command and we see what we expect to see, that the state is standby, preemption is enabled, active router is 23.2, there's that router's priority, our standby router is the one we're on, and our priority is 100, and it even says default 100, which of course your switch and then your T-shoot exams are not going to tell you, so that's another great value to have absolutely memorized. We got another one coming up as well. So let's go ahead and start with our interface tracking. And I'm going to hop over to switch 2 to get that done. Let me show you this command. Interface VLAN 100, standby 1, and what we're doing here is tracking. They call it priority tracking. That's fine with me. I don't care what you call it, as long as you know how to do it. So we're going to use track here, and then we got a huge list of interface types, plus a tracked object number. We're not getting into the numbers here in your CCNP studies. We're going to stick with the interfaces. So we're going to put fast Ethernet, maybe 0/3, and we have a decrement value of 1 through 255, but we can also just enter the command as it is. So what could be that decrement value? That default is 10. That's another really good value to have memorized. So everything being equal right now with what we've put in, switch 2 has a priority of 105, switch 1 a priority of 100. So if we decrement switch 2 by 10 and we have preemption enabled on the router we want to take over in case this interface goes down, then we should be set. So let's go ahead and go with that default. Then we're going to go to that interface and we're going to bring the line protocol down because we're going to shut the interface. And we get all kinds of messages right away. One that we haven't seen before, notice the top line, the top log message, I'd say the console message, tracking 5 state, 1 interface fast 03, line protocol up to down. Then all kinds of other things happen. Right after that tracking message, there's the one we hadn't seen before. Here's your HSRP state change message. We went from active to speak immediately. Then we get the usual messages we expect to see when we shut an interface down, change state to administratively down, line protocol change state to down, and this all happened in about a 3-second period. Then 12 seconds after we shut that interface down, the local interface has gone from speak to standby, the local switch I should say. So let's do show standby and we'll see the aftermath of what we did. You can see that priority 95 configured 105, so something made it go down, and certainly we know what it is. And here it is, right in show standby. Track interface fast Ethernet 0/3, state is now down, and it decremented by 10, and we see also the state is standby. Let's go over to switch 1. Pretty much know what we're going to see here, but we're going to run it anyway. And you can see now it is the active router is local, standby router is 23.2, which is .2, and it even shows you now that switch 2's priority is 95. So that's pretty cool. Now, the obvious question is, what do we have to do as network admins when switch 2's interface comes back up? You know, is the cutover going to happen immediately? Do we have to do something else? What do we got to do? Well, there's only one way to find out, by golly, and let's do that. We're going to reopen that interface. And let's see what our console messages are this time around. Okay, we've got a tracking state message in there. So the interface went down physically right after we did that with a no shut. And then here's your tracking state. It's already detected the line protocol's gone up. It even gives you the direction. Can't beat that. Down to up. So then we get the usual interface change state to up. Then the line protocol went up. What aren't we seeing here? We aren't seeing a message about this router becoming the active. It didn't even change any states. It just noticed, hey, I'm tracking this interface and it's gone up. But nothing else happened. Is that a problem with the log messages, you think? Console messages? Let's take a look. Well, the active router is still 23.1 and we're still the standby router even though the priority went up correctly. So tracking seems to be working fine. And here it even says track interface fast Ethernet 0/3, state is up, decrement is 10. What is going on here? Why isn't switch 2 taking over as the active? The answer is right in front of you. Preemption disabled. If we want this router to take back over as the active when that interface that we're tracking comes back up, and we probably do, then we have to enable preemption here as well. Always watch preemption. There's a reason I'm hitting you over the head with it. And I'm not going to put anything else in, and you can see immediately we get a state change from standby to active, and now everything that we wanted to have happen, switch 2 going back to being the active, seems to have happened. Yep, there you go. So active router is local, standby is 23.1, priority 105, the tracking information is correct. There is the key right there, preemption enabled. That is the key. If we want that router to become the active one again once the interface is fixed, and again we probably do or we wouldn't have made it the active in the first place, then we've got to enable preemption. Before we move to the next lab, I know another question that's likely on your mind now. It's like, well, should I just always enable preemption? You know, when I'm doing HSRP, should I always enable preemption? Of course, there is no one-size-fits-all answer to that question. Some people think it's a little bit of a security hole. I'm not really on that side. But it just depends on what your deployment is. It's not something I would just automatically put every single time on every single router, because of course you could have multiple switches in there in your group and you say, well, here's one I really don't want to become the active. So it's not something I would just do blindly, but I would just analyze your network, take a look at it. You're a CCNP, you look at it and say, here's where we need it and here's where we don't. But I would not just blindly enable it every time. On your exam and in your lab, and on job interview questions and in the workplace, the first thing I look for when I'm not seeing the kickover that I expect to see with tracking is making sure preemption is enabled on the switches that need it. So let's see, we're hitting about 11.5 minutes on this video. We're going to go ahead to another video, and I am going to reset the switches. We're going to do another tracking lab, and then I've got some other great labs for you right after that. So I'll see you in the next video. Time to do a little this and that with HSRP. A couple of things I want to show you, and the first one is changing the timers. Frankly, you can leave the HSRP timers alone, and I don't think the overhead is terrible. But if you really need to change these or need to change them on the exam, you certainly need to know how. What I've done since the last video is just I took all the old configs off, and the only thing I've put back on is the standby 5 IP command. That's it. So we're looking at all defaults here. And on switch 1, we're looking at a hello time of 3 seconds and a hold time of 10 seconds. And we can change that. Let's see how. I bet you can guess where we start by this point, certainly. And we go standby 5, and we're going to use the timers option for hello and hold timers. Now, we can set the hello interval in seconds from 1 to 254. You can specify the hello interval in milliseconds. That's pretty retentive, and you're talking to a retentive guy. That's pretty deep. You really don't need to go that far with it to do it in milliseconds. What I would do here, let's say we want to double that, and then you've got to enter a hold time, even if you're going to keep the 10-second hold time. Notice that we do not have a CR here, so you've got to put it there. We'll go with 15 seconds here, just pulling a rabbit out of my hat. So standby 5, timer 6:15 means we've reset our timers to 6 seconds for the hello time and 15 seconds for the hold time. Now, you'll note the only message we received from the console was configured from console by console. We didn't get any HSRP related messages. And you might have thought we'd get one because I haven't changed the timers on switch 2. They're at the default. Timers don't have to match between routers in an HSRP group. I strongly recommend, and Cisco also recommends, that you do keep them the same on all your routers. So the thing is, you don't want to get it out of whack to where you've got a hold time somewhere of 10 seconds, the default, and on another router you set your hello timers to 12 seconds. You know, then you're going to end up with some issues. So I would just keep my timers consistent. Changing them, not a big deal. Now you know how. Let's take a look at authentication. A couple of options here I want to show you. And the first one well, let's go ahead and bring up that standby 5. And we've got authentication right here at the top. And I'm not even going to show you plain text authentication, because if you're using plain text authentication, shame on you. You really should be using MD5, and I realize that Cisco router MD5, by their own admission, is not the hardest thing in the world to crack, but it beats the over-the-shoulder network attack where somebody just looks over your shoulder, sees what your password is, and comes back later. So we're going to use the MD5 option here, not MD6, and we've got key chain and key string. And when you're looking at these two right next to each other and maybe you haven't used them, it's like, well, what's the difference? Well, we're going to use a key string first. And a key string is just a fancy way of saying I'm going to enter a password. Maybe. There we go. And we're just going to put the password in here. We're not going to paste anything. We're not going to use that 0 or 7. And what we're going to do is just put CCNP right there with no null space. Watch that. And that's it. So now you'll notice we're getting a bad authentication from 172.16.23.2. That, of course, is because we haven't gone over there and set authentication up yet. So that can happen. What I did want to show you while we're over here was something in the config. Now I set this to MD5 authentication, but is that password of CCNP going to show up in the config itself? Could have done a filter all the way to the bottom, but that's okay. Yeah, it's right there under Interface VLAN 100. It's just sitting there. Now, what can I do to encrypt that? That's your first clue. There's a service I could use here. I love it when I remember to put the hyphen in. Service password encryption. That's an old CCNA friend of ours. And I'm going to use that right there. And you can see now I've got a key string with a lot of numbers that someone cannot look over my shoulder and say, oh, okay, the password is 03277822536. Doesn't work that way. Now let's go over to router 2 and set up authentication here. And it's just standby, then the group number, then authentication. And we're going to use MD5, of course, and a key string. And then CCNP, and then we will wait, and hopefully everything will be beautiful. See, state is active. Last state change was 9:13 ago, so let's keep that rolling. You see right here in the middle, authentication MD5, and it says you're running a key string, but it doesn't say which one. And this can take a little bit of time. Active router is local, so we've gone back to where we were, where active router is local, standby is .1. And we'll just go over to that one and make absolutely sure. And there you go. So that's authentication right there. Now that's with a key string. A key chain, I'm going to show you how to configure one of these in case you haven't seen one before. And it's a little tricky at first. You go key chain. Might be trickier than I thought. There we go. Keychain without the hyphen in the middle. So I love this. You know, it's keychain name here with the hyphen. When you get to the command, it's gone. So I do that quite often. Keychain, then it's what you're calling your chain. Your chain can really be thought of, you know, the way I've always remembered it, like a key ring. You got a key ring, and you've got a key to your house, and you've got a key to your car, and you've got a key to your office. Maybe some other keys you don't want to tell anybody about, and that's all cool with me. But the thing is, that's what a keychain really is. It's a series of keys. And what you do here, you create one. And what I would do here is just create one with one password right now. That's what I'm going to do. So let's just put I'm going to call it HSRP. Just so I can look at it later and say, oh, okay, that's what it was. Then you have to give it a key. Your first key is given a key number. So I'm just going to say, okay, key 1 is CCNP. Now, I do have some other options here. You see accept lifetime and send lifetime. That's another reason you get into keychains, because I know, especially when you start using, it's like, man, this is ridiculously complicated. Why don't I just use a password and I'll change the password if I ever want to? You can do that, but if you want to for other features, so you're going to use keychains for security features, you're going to use them, I believe, over in the routing course, the MP routing course as well, for other features. And what you'll want to do sometimes is say, okay, this key is good from this Monday to this Thursday, and then that's it. So, or you could do the send lifetime, how often you can, the valid range when you can be sent. So it really can be helpful when time gets involved. If this is a one-time only password, I'm probably going to go ahead and use the string myself. But what I will do instead is set key string, and here's where the actual password is. And that's it. And if I want to create another key string while I'm here, I would call it key 2 and go forward from there. Again, I know this looks a lot more complicated than just setting a password. And again, for authentication for something like this, for HSRP, personally, I'm probably just going to go ahead and set a simple key string. But for other features that you're going to run into in the future, especially if they're time related, these keychains really, really come in handy. Then what you would need to do is learn how to spell exit. Then what you would need to do is go under here. If you were using that keychain, MD5 keychain, and then you give it the name of the key chain, not the key string that you put in. So here I wouldn't put CCNP. What I would put here would be HSRP, the name of the keychain I just created. Again, first time you use keychains, you'll trip over it a little bit. That's no big deal. It's just part of the learning process, but it will come to you. And again, just going to mention it one more time. For time-related passwords, this is the way to go with keychains. That wraps up our time with HSRP, and you are, as you move to the next video, about to have the biggest case of deja vu in the history of network certification training. Because the next protocol we look at, VRRP, is going to look so much and feel so much like HSRP that you're going to wonder why we're even looking at it. But there are important reasons. First off, there are some important differences. Secondly, it is going to be on the test. And third, VRRP is our industry standard protocol, where HSRP is Cisco proprietary. So go ahead and take a quick break. I'll see you in the next video, and we'll start with the Virtual Router Redundancy Protocol, VRRP. We're going to start our look at Cisco switch security with port security, and it's a feature that you learned about in your CCNA studies. We're going to make sure that it's easy points for you on exam day as well, with several different labs where we're looking at almost really every option of port security, because there aren't that many options. And on top of that, the overall operation of port security is very simple. It's what we have right on the board. You got frames coming in on a port, and the switch asks itself, is this frame from a trusted source? That's it. That's port security. Now, of course, we have a few options we got to know about, but this is what's going on. And of course, the decision there is, well, how do we decide if it's from a trusted source or not? Well, what we're going to have is a table of secure MAC addresses. And it could just have one secure MAC address in it. It's on a per port level. So one port will have, some secure MAC addresses, another port may have others. And if frames with non-secure source MAC addresses come in on that port, the port takes action ranging from shutting down entirely to just letting you and I know about it. We're going to see all of this in action. We're going to see the tables I was talking about. We're going to set some static MAC addresses, see some dynamic ones, the whole bit. Now, before we do any of that, we have to enable port security, and we're going to do that at the port level with the switch port security command. And we're just going to fool around here with a couple of commands before we actually get into some labs. With switch port security, we have a couple of options there: aging, MAC address maximum, and violation. We're going to see all of those in action. But switch port security by itself is also a legal command. And what it does is actually enables this function or feature on the port. So then, of course, you press enter. Oh, and you get rejected. Well, you get rejected here because it says fast Ethernet 0/1 is a dynamic port. Okay, what do you want for my life? What's that got to do with it? The problem here is that you can only enable port security on a port that has absolutely no chance of becoming a trunk. Not that it's trunking now, that it can't possibly become a trunk port in the future. And we know what that means. We got to make it an access port. Because we could look at the switch, and I believe right now we don't even have any trunks. We have 0 trunks on the switch, but I still have to make that port an access port. So let's go ahead and make that happen. Let's try that again. Switch port, and boy, yeah, that's skipping right there. There we go. Sorry about that. And the VLAN doesn't exist, which is always nice enough to create it for me. And let's try switch port security again now. And we are enabled. You're not going to get a confirm message that says you just enabled port security, but we can confirm it with one of several show commands. A lot of people spend all their time with show port security, and there's nothing wrong with that command, but there are definitely some other show port security options I'll show you in the labs ahead. Right now, though, let's go with show port security. And going from left to right here, secure port, then it's got the number of maximum secure addresses, then the current secure addresses, then security violation and security action. And the key here is, really want to point this out, a lot of people, I should say a lot of people, some people, their eyes go straight to that shutdown, and they say, oh, well, you know, the port is shut down. The port is not shut down. Here, the situation is, this command is just telling you what the security action will be if there is a security violation. But we haven't had any security violations, so far we're good to go. I have a feeling that just might change in the labs ahead, but we're going to stick with that for right now. So let's see, we've got show port security. I'll go ahead and show you a couple of others here, a little advanced work. Here's show port security address. And we can see that it shows you what VLAN it is, the MAC address, the type, the ports, and remaining age in minutes. And we have a dash there, which means probably it's been disabled. Also note that the bottom of both of the outputs, show port security address and show port security, total addresses in system excluding 1 MAC per port, and then max addresses limit in system excluding 1 MAC per port, 6,144. That's a lot of secure addresses. So we're going to come back and see these tables in action as we proceed through some labs. Just want to give you a little feel for the show commands right now. And we have one more I want to show you. It's show port security interface, followed then of course by the interface type. And going from top to bottom, you can see port security is enabled, port status secure and up, which is a great combination. Violation mode is shut down. That is the default. You likely remember that from your NA studies. Aging time of 0 minutes, absolute. Aging type, absolute. We'll go over those when we change the aging types. Maximum MAC addresses of 1, total MAC addresses of 1. Configured MAC addresses then is 0. Sticky MAC addresses, we've got a lot of address types here, 0. What I like about this command, it shows you the last source MAC address that came in and the VLAN number of it. That's pretty cool. And it also shows you the security violation count. Again, just want to show you those now, and we'll see them in action during our labs as well. Let's go ahead, go back to the port, switch port security, and look at our options here. And we're actually going to start with maximum, max secure addresses. And you can see the range is 1 through 6,144. And if you're laughing, it's okay. The first time I saw that many max addresses on one port, I kind of laughed too. And the default is 1. Obviously, you can't set it to 0, because if you did, you'd be disabling it. And the key here again, the default is 1. I would not recommend putting 6,144 maximum addresses on a port, but that's the only reason. That's the reason we have the maximum command. Simply, what is the maximum number of secure MAC addresses we can have on this particular port. Now with MAC age, let's look at violation right now. Violation, this is the action that's going to be taken if there is a security violation. The default is shut down. I believe we saw that in show port security interface. Saw it right here next to violation mode. Zing, there it is. That's shut down. Our other two choices are protect and restrict. And we've been around Cisco certification exams long enough to know that if we have some options like that, we better really know the difference. We're definitely coming back to those, but I want to show you these right now. The default port security, again, it's shut down. And it does exactly what it says it's going to do. The port is placed into error disabled state. Very important that you know that. It's error disabled. Manual intervention is needed by default to reopen that port. So what happens there is you and I, as the network admins, have to fix the problem first and then do a shut no shut on the port. And with shutdown mode, an SNMP trap message is also generated. Now, I know you may think it sounds silly when I say we have to fix the problem first and then do a shut no shut on the port. Well, if you do the shut no shut first, it's going to be fine until the error happens again, which will probably just take a few seconds. Protect mode, it just drops the offending frames and no other action is taken. Our middle ground security mode is restrict, and the non-secure frames are dropped. There's an SNMP trap notification and a syslog message generated, but the port remains open. So if you want that port to remain open, but you want these other notifications, you need to go with restrict. But definitely I would know what all three of those modes do. So let's see, we've taken a look at violation and maximum. Let's take a look at MAC address here. Okay, so we've got Triple H, I like it, 48-bit MAC address. So we can put a MAC address in there if we want, apparently. And then we have something called sticky. Ew. For some reason, I always just see, Pepsi being poured into a router or something when they say sticky address. I have no idea why. Anyway, sticky addresses, configure dynamic secure addresses as sticky. We will do a lab on those, but that just means that these are addresses that are dynamically learned, but they are going to be kept on a reload. We'll do a lab with that as well. Let's go ahead and look at our other option here, our aging option. We have static, time, and type. Now, a configured secure address, a statically configured one, as you would expect, is not going to age out, because I can't think of anything that we configure at the command line statically that would age out dynamically or automatically. It's rare that you're going to want to do that. You may have very specialized situations where you want to enable aging for a configured secure address, but it's not something we do terribly often. Then we have time and type, and we've got the aging time in minutes, and you put anything in from 1 through 1440, so that's how long it would be before a dynamically learned address was actually aged out. And then you have your type, which is absolute and inactivity. The default is absolute, and that just means the clock starts ticking as soon as that address is learned. It doesn't matter how often it's refreshed. Inactivity, of course, the aging is based on the inactivity time period. If we don't hear from that source MAC address for a while, then we're going to flush it out. So this video, what we've done here is just an introductory look at the commands. We're going to go back to every single one of them during a lab and work with them, but I want you to see them all in advance. And what we will do here on the very next video, we're going to have router 1 or host 1 at 172.16.23.111, and then our other host is going to be at 172.16.23.222. We're just going to use that to send some pings and have some different source MAC addresses, that kind of thing. And like I said, we'll see all of these things in action. And we will start with that at the beginning of the very next video. I'll see you there. I did want to clarify on the diagram that Fast Ethernet 0/1 is the interface leading to host 1 and Fast Ethernet 0/2 is the one leading to host 2. We're going to see port security in action, and I'm going to use a secure MAC address different than the one you see on the board. Because what we're going to do here is on that port leading to host 1, we're going to enable port security, and we're going to put a secure MAC address on there that cannot possibly match traffic that's actually going to come in from host 1. So what I like to do, especially in lab environments, not a bad idea for production either, is before, let me check that port. Before I start working with port security, I like to shut the port down. And I've already done that on 0/1. It's administratively down, because I don't want any traffic from something that I don't know is running or forgot was running to trickle in and trigger port security when I'm in the middle of it. Because right now, if I look at that table, our address table, you can see that it's empty. So right now I've got port 1 shut, so it can't possibly learn anything. And let's go ahead to fast 01, and we'll do a switch port security. That's to enable it. Then we can use our up arrow. And let's look at our options again. We've got aging, MAC address, maximum, and violation. Right now we're going to work with MAC address. And we've got Triple H, and we've got sticky addresses. So right now we're going to work with the regular MAC address type. We've got a lab with sticky addresses coming up later. And I'm going to define the all A's MAC address as a secure address. So far so good, and really that's all there is to it outside, of course, testing it. But let's look around at show port security commands before we do that. And you can see here's our secure port 0/1, one maximum secure address. The current count is 1 because it's counting the static one we put in. There haven't been any security violations yet, and a security action is at our default of shutdown. So let's look at address. And there's the VLAN 100, which by the way I've put both hosts into during the break. And there's the secure MAC address we've configured. And notice it even says type secure configured. That means that we statically entered it. Here are the ports that we're considering that address to be secure on, and our aging is disabled right now, so that's why we have a dash there. It's disabled by default. So let's run show port security. Let's use our up arrow there. And we're going to take it to the interface level. Very important difference I want to show you here. We see that port security is enabled, which is a good thing because we just enabled it. Port status secure down. I want you to take note of what this says when the port is administratively down, which it is right now, as opposed to what it's going to say if and when port security shuts it down. Everything else pretty much exactly what we'd expect. And here's the last source address it saw. That was during, and that's actually the source MAC address of the interface on host 1. So it's holding that because I did something with that during the break and some frames came in on it. But we have a security violation count of 0. So let's see what happens though when we do a no shut on that. And I'll save that. I'll go on over to 1 and send some pings now that the interface is up. And it may have already gotten some traffic, but we'll see how that goes. And let's see what we get here on switch 1. We send some pings from host 1. And we're getting something. And we're getting some more. And you know what? None of that looks good. Not one little bit of it. But it is what we expected to see. Because when those frames came in with a non-secure MAC address, first, the P-secure violation error detected on fast Ethernet 0/1, and the switch put fast 0/1 in error disabled state. Right with that, I don't even want to say after that because you see the timestamp. It happened at the same time. Here's your port security P-secure violation message. Security violation occurred, and it was caused, I know most of that one word is off, but it was caused by MAC address, and there's the address that caused it on the port. So we're even finding out what the non-secure MAC address is just from the console messages. Then we see the usual suspects as far as the line protocol and the interface going physically down. So let's start doing our show commands, because let's just say you walked in on the middle of this, or the exam or job interview or anything just plops you right in the middle of it, didn't show you these console messages like, okay, tell me what's going on. Well, first off, we could just look at the interface. We don't have to use a port security command to get some important information here. Now, we get a ton of info, but what we're really interested in is at the top here, the interface is physically down, logically down, and it's error disabled. That is the big important part right there. So now let's revisit our show port security commands. We'll start with show port security. And now the important difference from what we saw earlier, of course, security violation count is 1. So show port security tells you there has been a security violation on there. It's not giving you much more information about it though. So let's do show port security address. And this really looks the same as it did before because this is just showing you your secure MAC address table. It's not going to show you violations, anything like that. Where we might get some more good information is here. And show port security interface fast 0/1. Port security is still enabled, and note the status. It is secure and shut down. Just because you see the word down next to port status, it doesn't mean that port security has shut the port down. It just meant that it was down. And we know why, because it was administratively down. Everything else, here's your security violation count. That's the big difference right there. And again, it's even showing you the last source address, VLAN 100. And there you go. So we know now what it looks like with 4 different show commands and the console messages when a port goes down due to the shutdown mode in port security. So now you and I as the network admins have to do 2 things. First off, we have to fix the problem. We should do that first. And then we can reset the port. Because by default, if a port is error disabled, we have to fix the issue and then reset the port. It's not going to reset itself by default. So let's go ahead and take care of business here. First off, how would we resolve the issue? What do? We just take that static entry out. And there's no switch port. All I did was do a Control-A to move the cursor to the front and type the word no. Saves you a lot of typing. We can do a show port security address just to verify it's come out. And you can see now the table is empty. So now this is interesting because what's going to happen when we reset the port? The port is going to have a maximum of 1 secure MAC address, but we have it statically configured in it. So that means that the very next source MAC address that comes in on a frame onto this port, that is going to be learned as the secure MAC address. That's the way it works. So let's go ahead and just do our shut no shut here. We'll wait until everything comes administratively up as opposed to administratively down. And of course, we're going to check that interface before we go any further. And we can see now that we have gotten rid of the error disabled message. So that is a good thing. Now, let's see. I don't think that we've learned that address yet. So let's go over to 1. And we'll send those pings again. And we're sending some pings through that switch, so let's give it a few seconds here. We haven't seen any secure violations, port violations, anything like that so far. Is our interface still up? Should be. Yep, it's still up and up. And there is our dynamically learned MAC address, secure MAC address. You see the big difference here is that the type is secure dynamic. So for a source MAC address to be considered dynamically secure, there's got to be a difference between the number of maximum addresses the port can learn and the number that it's actually learned. So we see now that since we had the port set for 1 address to be learned and no static configurations, the very next address it learned, very next source MAC address, was going to be considered the secure one. So we're good there. Let's go ahead and just run show port security. And we can see that it has indeed learned 1 address. We just verified that by looking at the table. And more importantly, much more importantly, the security violation count is empty. So finally, you think I'd remember that after all these years. Interface fast 0/1. And we can see the combination we really like to see, that port security has indeed been enabled. We knew that part, but finally the port status is secure and up, and that is what we want. You can also see the security violation count is now at 0. The last source address VLAN is the same as it's been. So that is port security in action. That's our shutdown mode. And in the very next video, I think we're going to go over to switch to host 2 and work with that port a little bit, and you'll see some other real world scenarios in action. I'll see you on the very next vid. Just taking a look here at our secure MAC address table, and we're going to make this grow a little bit. We're going to work with fast Ethernet 0/2, the port leading to host 2, and we're going to configure some secure MAC addresses that we know aren't going to work, and we'll play with the maximum a little bit and see what happens. It's going to illustrate a point that I was describing in the last video as well. So let's go ahead and go to interface 0/2. First thing I'm going to do is shut it down because I don't want it learning anything while I'm in the middle of this config. So let's go ahead and enable port security to begin with. And now let's change the maximum here a little bit, see what that looks like. Like I said, I wouldn't go to 6,144 secure MAC addresses on a port. Let's set it for 3. And now I'm going to use the MAC address option again. And we'll go with the static one. And I'm going to try to make up another one on the fly here. Hey, it worked. So we've got 2 addresses defined, but we're allowing the port to have 3 secure MAC addresses. So the theory holds that the very next the very next MAC address it learns on that port will become a secure dynamically learned address. So we're going to test that theory out. And let's go ahead and look at our tables here again before we get started. Show port security. You can see the 2 configured addresses are already in there. And you can see they're labeled as secure configured, and you see the port numbers as well. And let's do a show port security interface fast02 while we're here. And again, it's secure and down for port status because the port is administratively down. 3 MAC addresses, 2 total, 2 configured, no sticky. It hasn't seen anything come in on the port, so you see a last source address of all zeros. And that's it. So let's go ahead and do a no shut there. I know that address had to come, the interface had to come up. 23, one will ping host 1. And I sent the pings and then came back on over to the switch because I didn't need to hang around to see them go through. And we don't see any port security messages, so that's always a good thing. So let's go ahead and look at our address table. And you see now 2 secure dynamic addresses. And one of them, the new one, is for Fast Ethernet 0/2. These are all secure MAC addresses for 0/2. We set a max of 3, 2 configured, 2 static ones. Of course, that let it learn the next MAC address it learned as a dynamic one as well. So we've got 1 secure dynamic and 2 secure configured, all for Fast Ethernet 0/2. Nothing to it. And let's go ahead and run. I should be able to up arrow to that one. There we go. And that's it. And we see now that great combination, port security enabled, port status secure is up. Maximum MAC address is 3. Now the total overall is 3. 2 of them were configured. 1 of them is dynamic. That's the one column they don't have here. They do have a column for sticky addresses, which we will be working with soon. And there's the last source address that it saw come in on that port and the VLAN. So that's it. That proves the theory. And we always like seeing that stuff work. So you want to watch that if you got a difference between the total number of addresses it can learn and the number of static addresses. Because you may want this. You know, this may be fine for your purposes, but then again, it may not be. So just be aware that that's what can happen. That's the end of this lab, and we'll work with another port security feature on the very next video. This is going to be an important video for more than one reason, and one of the reasons you're seeing on the screen right now is that we're looking at the aging command. And I was just doing this as I was uploading the last vid. And just going through the choices, and I want to review these with you one more time as far as aging goes. Now the aging of static entries, statically configured secure addresses, again, not something you're going to do terribly often, but it's good to have the option. With type, you're looking at absolute, where the clock starts running, and that's just it. Inactivity is aging based on an inactivity time period when we say, okay, if we don't hear from you for so many seconds or so many minutes, then we're going to drop you out. And again, absolute is the default there. Now, a quick CCNA review. Do you remember what the time, how long a dynamically learned MAC address stays in the table if it's not heard from again? 300 seconds, right? And we have you learn it that way because 300 is the way you have to put it in if you want it in for 5 minutes. So just playing around here, we're going to go ahead and set this for the same value. And nothing to it, right? So you just put the aging time and then the value in that you want. And I wanted 300 seconds, so that's what I put in. And how would I verify this? MAC address. Yeah, because here's one way to do it. You've got remaining age 300 next to the dynamic address that was learned on 0/2. So there you go. So I got it right, right? And if this is the first time you're watching the video, I hope you're saying, no, you're getting it wrong. This is the other important reason that I'm showing you this command. And it's a little bit of a dad lecture, as I tend to call it, but I don't want to laugh it off because this is really important stuff. And those of you who got your CCNA with me, I'm pretty sure you know what I'm about to say. Anytime that you are using a command in the Cisco iOS that has any unit of measure, whether it's time, data, anything else I'm not thinking of right now, always use iOS help to see what the unit is, especially with time, because sometimes your commands will take seconds, sometimes they'll take minutes, sometimes they'll take seconds, hours, days. I mean, there are a lot of different ways to combine these things. And if you think, okay, I'm going to set this to 10 minutes, and you enter 10 in for the value, but it's being entered in seconds, then obviously you're not going to get the answer that you want. You're going to have a bad time, and you're going to miss an exam question too. We don't want that. The problem here, and let me just go right back to 02. The problem here is that with aging time, it's aging time in minutes. So if I wanted to set this to 300 seconds, I would not put 300 here, right? I would put 5 here. That's what I would need to do. And the reason I bring that up is because the command to change that for the MAC address table is MAC address table aging time. I've got an extra dash in there. MAC address aging time, and you set this in seconds. This is the little kind of thing that causes you big problems on the job, and of course it can cost you points on the exam, and again, we don't want that. I'm not saying you got to memorize every single value of every single command in the iOS. That would be silly. Knowing these two, I think, is a good idea. Again, if you are changing the aging time for your secure MAC address table, that is the switchport port security aging time command, and that value is entered in minutes. If you're changing the aging time for your general MAC address table, then you're doing that in seconds. And that's a really good habit to get into, period, on the job and on the exam when the simulator engine lets you do it. Again, always check your iOS values like that because, like I said, some are in seconds. There's no way to memorize all of them, and you don't want to do it anyway. So that is it for this particular video. So a good reminder there about your iOS check and also about changing the aging time on your secure MAC address table as well as your general MAC address table. We are going to take a look at those dreaded, nasty, sticky addresses in the very next video, and we'll see them in action. I'll see you there. I wanted to show you a couple things about our address table at this point, our secure MAC address table, that is. And first off, the rather restrictive aging that we enabled at the end of the last video has taken effect because the dynamic entry that was on 0/2 has now totally aged out. The one we have on 01 is still there because aging, as with just about everything else we do with port security, it's on a per port basis. So we didn't change aging on 0/1. Now, the only issue with a dynamically learned secure address is that on a reload, we're going to lose it. That entry will be flushed out. That'll actually happen if the port just gets reset. If I do a shut, no shut right now, I believe we will lose that address. Let's go ahead and give it a try. We'll do a shut, and then a no shut for it. And you can see it's actually been removed, and I'll do that one more time. Now, of course, with one address, you could say, well, is it really that big a deal for the switch to have to relearn one dynamically learned address? I would say no, not really. But of course, we could have dozens of dynamically learned addresses, and maybe we want the switch just to come up and already have those if it's reloaded. Let's see if it's learned that again yet. Yep, there it is. So it didn't take long. We had some other traffic come in, and it was carrying that MAC address, and it's been listed as secured dynamic. But what if we want that to be kept even if the port goes down? What if we want it to be kept even if the switch is reloaded? That's where sticky addressing comes in. What you're doing with sticky addressing is these secure dynamic addresses are then written to the running config. So they're kept on a reload. You just do a yes when it says you want to save your work if you haven't done it yet. When you reload the switch, and it's going to save them. And when the switch comes back up, the addresses are already there. They don't have to be learned again. That's not a bad deal. So let's go ahead and enable that on that particular interface. And it's switch port security. What now? There's no sticky option. Where is it? It's in MAC address. And then sticky is at the end of that. And there are no options. We're always happy to have no options there. So now let's run show port security address and notice the change under type of that same address. We've seen it as secure dynamic for the last couple of videos because frankly that's what it was. But now it's listed as secure sticky. So let's go ahead and shut that port down. And usually that'll get rid of your dynamic addresses in a heartbeat. And it would here too, but this is no longer a dynamically learned address. It is a sticky address, and therefore it's going to be kept in that particular scenario. So I will go ahead and do a no shut. And it's going to say the exact same thing. But again, it's going to be kept on a port reset or even a switch reset. It's a pretty cool feature. Actually, what we will do, I am going to pause this video because this switch does take a few minutes to reload, but I'm going to go ahead and just reload the switch. And yeah, I want to save my changes. System config has been modified. It's going to ask you if you really want to proceed with the reload, and I said yes. So what I'll do is go ahead and just pause the video right now, and once the switch comes back up, I will unpause the video. I'll do a shut no shut on the video, and we'll see if those addresses are still there after that reload. And we're back. Just wanted to show you some of the stuff that we're going through here, and I did indeed reload. And you remember what POST stands for, right? What are those? Power on self-test, little test it runs before it really starts booting. So all our posts passed and everything. We got the warning about the cryptographic features, don't mess around, and some information there about the switch itself. And then finally, once we got through the intro messages, I ran show port security address, and there is the address. It's still listed as secure sticky. So some good stuff there. That's all a sticky address is. That's all there is to it. And on the very next video, we're going to go back to something about the error disabled ports. Because I'm sure you remember I put a little emphasis on by default, error disabled ports have to be manually reset. There is a way around that. It's not really a workaround because it is a Cisco feature. It's built into the switch about automatic recovery from an error disabled status. And I will show you all about that, and we'll test it on the next vid. See you there. We're going to see the error disable recovery mode in action, I hope, here in this particular video, in this particular lab. And the change that I've made here on Fast Ethernet 0/2, the only one really, you can see it's secured down next to port status, so you know that I have the port administratively shut down. But what I've done is changed the maximum MAC addresses to 2. We had it at 3, and we know that we have 2 statically configured ones for that interface. We've seen that in several of the past videos. And as a matter of fact, I'll just review it right here. We know we still have those 2 configured addresses from an earlier video. And since we set maximum MAC addresses to 2, now it can't learn 1. So when that source address of 001B D4C2090 comes in, the port should go into error disabled mode, and we know what we have to do from there. But before we open that port and allow that to happen, we are going to put error disabled recovery into action. And we're going to do that with the error disable recovery command. And by the way, I know that there always seems to be a hyphen in error disabled, but in this command there actually isn't one. So we've got error disable recovery. Let's try that again. And we've got cause and interval. Notice that this is not a port level command. I think this is the first non-port level command we've really run into with port security. That's because this is not a pure port security command. As you're going to see in a moment, you can use it for just about anything that's going to that can put a port into error disable mode. So we've got error disable recovery. Let's go with cause first. And this is a lot of causes. That's a lot of causes, a lot of different ways that a port can go into error disable mode. They barely actually don't quite fit all on one screen. So you do have the all option at the top where it enables the timer to recover from all error causes. That's a little heavy for us right now. We're going to stick with the port security. Pardon me, goodness, the port security violation. And that is right here with P-secure violation. So that's what we're going to go with here. And we're always happy to have no options. So really that's it. First you have to pick the cause. And let me show you, there is a show error disable recovery command. And this is going to show you whether it's been enabled or disabled for every single one of those reasons. And you can see the only one it's enabled for right now is our port security violation. The other important value we see at the bottom is the timer interval 300 seconds by default. We're not going to stick with that. It's also going to list the interfaces that will be enabled at the next timeout. And in this case, there aren't any because we don't have any that have actually been put into error disabled mode because of a port security violation. Let's call this command back up. And we're going to change that timer. Okay, interval. Got me. Interval, and the minimum we can set it to is 30 seconds. So there's no such thing as an instantaneous recovery attempt from error disable mode. So let's go with 30. And no options, and so far so good. We'll go ahead and verify that before we open that port and make the port go into error disabled mode. And let's try that again because I came out of it too early. There we go. The timer interval's been set to 30 seconds. So we're all good there. Let's go ahead and open that port. And I will stand by to send some pings when I see the interface come up. And let's give it a moment here and see if we end up in error disabled mode. And there we go. So we're seeing what we expect to see. We're seeing that because of a port security violation was detected and it's been put into error disabled mode. I'll go ahead and run the interface command. Actually, let's run show error discovery. And now you can see at the bottom that port is listed interfaces that will be enabled at the next time out, and time left is 11 seconds. Grab a swallow there, and now we're getting a message that we haven't seen before, and we'll see if this is successful. It looks good so far. And you can see it's an error recovery message attempting to recover from P-secure violation error disable state on fast Ethernet 0/2. Then the interface comes up, and then the line protocol comes up. And now we're getting another port security message. And this is why I was hammering early. You know, we always have to fix the problem before we try to bring the port out of error disabled mode. And that's the problem right now, of course, is going to keep going into it as long as it keeps getting some kind of data from host 2. So it is not perfect. It's not going to fix the problem for us. But what we need to do here is just go ahead and make the maximum of 3 addresses, something like that. And then when it comes out of error disabled state, it will stay there. But I did want to show you that particular feature. So let's go ahead and try to get that fixed. We're going to do an interface fast 02 first and do a shut. So we don't have to keep running into that. And then we're going to do port security. Nice try. Max 3. And let's see if that works. Let's see what happens here. Let's just sit back for the ride. I'll take a sip while you take one. So everything's come up so far. Let's check our address table. Actually, our error recovery table. Looks like everything's good. And we're enabled, secure up. We love that. And you can see the maximum MAC addresses did take effect. And now we are showing 3 total MAC addresses. And even better, no security violation. And that's it. So now we have 1 secure sticky address, 1 secure dynamic address, and 2 secure configured addresses in our table. And you also got to see the error disable recovery mode command, which in the right place is a fantastic command. That wraps up our time with port security for now. We're going to head into .1x based security next. And then after that, we'll do some span and some other great stuff. So I'll see you in the very next video.